Let's join. Tuingie. If you are in, comment you are in. Today we will be learning on linear motion. And what we are going to do today, we are going to do on examinable areas on linear motion. I don't want to go through the topic ati kutoka mwanzo mpaka mwisho. I want to focus on the main examinable areas. I want to focus on the main examinable areas, or where the exam is assessed from, so that we can be able to interact and see what we are expected to do. Keep joining. Keep joining. Keep joining. Tuendelee kujoin. Tuendelee kujoin. Linear motion. Linear motion. This is the topic where we will be learning about three things. In linear motion, we will be learning about distance. We will also be learning about speed. We learn about time. And we also learn about acceleration. Distance, speed, time, and acceleration. That is what we will be learning about. And so all this is what entails linear motion. Linear motion. All that is what entails linear motion. Distance, speed, time, and acceleration. Haya. So what we are going to be learning here, we will learn about velocity time graphs. We learn about velocity time graphs. We will also learn about relative speed. And we will also learn about speed, distance, and time taken. Speed, distance, and time taken. Speed, distance, and time taken. These are the major areas that linear motion entails. And I think what we should be starting with now, we will start with we'll be starting with Yeah, tutaanza na distance or velocity time graph. Ngoje kidogo. I hope you have written this down. So wacha tusianze na hii because there is a concept I want to explain. We will start with speed, distance and time taken. That is what we are going to start with, and we are going to do questions. Tutafanya maswali. So andika hizo. Distance, speed and time taken. Distance, speed and time taken. So we are going to have an example. We'll have an example, and our example is a bus takes 195 minutes. A bus takes 195 minutes to travel a distance a distance of 2h plus 30 kilometers. 2h plus 30 kilometers at an average speed of h minus 20 kilometers per hour. Full stop. Calculate the actual distance. Calculate the actual distance traveled. Full stop. Give your answer in kilometers. Three marks. That is what we are going to do. Give your answer in kilometers. That is what we are going to do. So we've said we will start with distance, speed, distance and time taken. We do some questions based on that. Then afterwards we'll proceed. We'll gravitate from that to something else. So the question reads, a bus takes 195 minutes. So what is 195 minutes? 195 minutes is equal to time taken. So time is 195 minutes. So if you want to convert this into hours, you will take 195 divided by 60. And when you take 195 divided by 60, it is going to give us, by 60 it will be 3 because of 180. Then we will be left with 15. So it will be 3 whole 15 over 60, which is the same as 3 whole and a quarter. So our time taken, we can replace it here with 3 and a quarter of an hour. 3 and a quarter hours. So 195 minutes is the same as 3 and a quarter hours, simply because 195 minutes divided by 60 minutes will be equal to 3 and a quarter hours. Then we are told a bus takes 195 minutes to travel a distance of 2h plus 30. So our distance is equal to 2h plus 30 kilometers. 2h plus 30 kilometers at an average speed of h minus 20. At an average speed of h minus 20 kilometers per hour. So you can see we have time, we have distance, and we have speed. So the question asks, calculate the distance traveled. Calculate the distance traveled. Give your answer in kilometers. So we are supposed to find the distance traveled. How do we find the distance? What is the formula of finding the distance? The distance is equals to speed multiplied by time. That is the formula we use to find distance is equals to speed times time. If you want to know where I got this formula from, we have a triangle here that we use, and this triangle has a distance here, it has speed and it has time. So for you to get speed, we say it is d over t, distance over time taken. For you to get time, it is equal to distance over speed, distance over speed. And for you to get distance, distance above, it is speed times time, speed times time. That is how we determine that. S is d over t, t is d over s, and d is equal to speed times time. So when we talk of distance is speed times time, at least you have seen where it comes from. So what we are now going to do is that we will now equate these expressions into this formula here. Our distance is equal to 2h plus 30. So that is 2h plus 30 is equals to our speed. Our speed is h minus 20. So it will be h minus 20 multiplied by, what is our time? Our time is 3 and a quarter. 3 and a quarter is the same as 13 over 4, because 4 times 3 is 12. 12 plus 1 is 13. So that will be equal to 13 over 4. And then we can proceed. So this will be 2h plus 30 is equals to 13 over 4 times h. It will be equal to 13 over 4h minus 20. 13 over 4 times 20 by 4 1 by 4 5. So it will be minus 65. Minus 65. Why? Because when we simplify by 4, we will get by 4 1 by 4 5. 13 times 5 is equal to 65. Is equal to 65. So what we are now going to do here, we will now put the right terms together. We will take this to the other side and we can bring this to this side. So we are going to have 2h minus 13 over 4h is equal to negative 65 minus 30. Why minus 30? Because when you take positive 30 to the other side of the equal sign, it is going to be a negative. So what is 2h minus 13 over 4h? We can take this as over 1. So our LCM is 4. 4 divided by 1 is 4. 4 times 8h is equal to 4 times 2h is equal to 8h. 4 divided by 4 is 1. 1 times 13, it will be equal to minus 13h is equal to minus 65 minus 30 is equivalent to minus 95. Is equivalent to minus 95. So as we proceed, what we are going to do now, 8h minus 13h is equivalent to negative 5h over 4 is equals to negative 95. Is equals to negative 95. So because we want to be left with h on one side, we will multiply by 4 over negative 5, then by 4 over negative 5. Once we do that, this will simplify by 4 1 by 4 1 by negative 5 1 by negative 5 1, and we will be left with x is equal to negative and negative will cancel. 95 divided by 5, this will be by 5 1 by 5 4 by 5 1, because of 5 remainder 4, it will be 19. So what is 19 times 4? What is 19 times 4? 19 times 4 will be equivalent to 76. So when we get 76, our question was asking, calculate the actual distance in kilometers. Calculate the actual distance. Remember, distance was equal to 2h plus 30 kilometers. And we already have our h as 76. So we will equate our 76 into our expression for distance and get distance is 2 multiplied by 76 plus 30. So when you multiply 2 times 76, you are going to get 152. 152 plus 30, it will be equivalent to 182 kilometers. It will be equal to 182 kilometers. So that will be our distance. That will be our distance. That will be our distance. So we can do another question. So let's do our next question. So we don't have many questions resonating with that. Many questions resonate with the relative speed. But before we get to relative speed, I want us to work on velocity time graphs. Velocity time graphs. Velocity time graphs. So when we talk of velocity time graphs, what we are generally talking about is that in velocity time graphs, these are graphs drawn. These are graphs drawn for velocity in meters per second against time, and time is in seconds. These are graphs drawn for velocity in meters per second against time. Remember, velocity is a vector quantity, also a representation for speed, and then the time is in seconds. So when we talk of velocity against time, this is what we mean. It is velocity on the y-axis against time in seconds. So velocity is in meter per second against time in seconds. That is the format in which we draw what we call a velocity time graph. So what we are going to do now is that in this moment, I want us to, we can probably have some we can probably write down some formulas that we are going to interact with in this course, or we can do some questions related to velocity time graphs. Velocity time graphs. So one of the questions that you really need to understand on velocity is that average velocity, how do we find average velocity? We find average velocity by taking initial velocity plus final velocity over 2. So average velocity is equal to initial velocity plus final velocity over 2. So why is it average? Also means mean velocity, mean. So average velocity or mean velocity is the first velocity initial plus final, then divide by 2. Why 2? Because there are 2 of them. So what we are going to do is we are going to have some examples related to this. Another formula that you really need to know is the formula on acceleration. How do we find acceleration? Acceleration is equals to final velocity minus initial velocity over time taken. Over time taken. Acceleration is equal to final velocity minus initial velocity over time taken. Final velocity minus initial velocity over time taken. Final velocity minus initial velocity over time taken. Once we do that now, we can get some questions to do based on what we have just discussed. The question that we are going to be doing is example 1. The initial velocity of a car is 10 meters per second. Is 10 meters per second. Full stop. The velocity of the car after 4 seconds is 30 meters per second. Find its acceleration. Find its acceleration. Find its acceleration. 2 marks. Find its acceleration. 2 marks. I hope you are following. I hope we are together. I hope tunaendelea vizuri. If you don't understand, kindly comment so that I'm going to do a recap on what you have not understood. So, the initial velocity of a car is 10 meters per second. The velocity of the car after 4 seconds is 30 meters per second. Find its acceleration. So remember, we have said that we already have the initial. So our initial velocity, we represent it by u. Those people who do physics understand more about u. So initial velocity represented by u is equal to 10 meters per second. Then we are told after 4 seconds, that is time taken. Time taken is equal to t. It is 4 seconds. Then we have the final velocity, which is represented by v, is equal to 30 meters per second. Is equal to 30 meters per second. So, how do we find the acceleration? So how do we find acceleration? Acceleration, the symbol for acceleration is a. So we don't have acceleration. That is what we are supposed to determine. How do we go about finding the acceleration? So for us to find acceleration, remember we said that acceleration is equal to final velocity. The formula for final velocity is v minus initial velocity is u over time taken is t. So you can say that a is equal to v minus u over t. Why? Because a is acceleration, v is final velocity, minus u is initial velocity over time taken in seconds, which is represented by t. So what we are going to do in this case, our acceleration will be, what is our v? Our v is 30. Our initial velocity is 10. And our time taken is 4 seconds. So a will be 30 minus 10 is 20. 20 divided by 4 is 5. So our acceleration will be equal to 5 meters per second squared. 5 meters per second squared. Why per meter per second squared? Because the SI unit for acceleration is meters per second squared. V that a unit for acceleration. It is per second squared. Meters per second squared. Have you understood? Have you understood? Kama umeelewa sema yes. Like that live. Hata usishinde ukicomment. Just press that button for liking and reaction. Just react for me to know that tuko pamoja. React for me to know. Don't say haujaelewa ama umeelewa. Just react on that video. Keep reacting ili nijue tunaelewa ama hatuelewi. So let us do example 2. Example 2 is reading a bus accelerates from a velocity of 12 meters per second to a velocity of 25 meters per second. Full stop. Find the average velocity. Find the average velocity during its interval. During its interval. During its interval. So in this question, tunaambiwa a bus accelerated from a velocity of 12 meter per second. So that is initial velocity, ambayo tuliita u, which is 12 meter per second. Then tuko na final velocity, which is v, it is 25 meters per second. Then we are being told to find the average velocity, which we said the formula initial velocity plus final velocity over 2. That is how we said we find average velocity. So average velocity itakuwa initial velocity is 12 plus final velocity is 25 divided by 2. So 25 plus 12 is 37. 37 divided by 2 is equivalent to 18.5 meters per second. 18.5 meters per second. 18.5 meters per second. 18.5 meters per second. The next question, example 3. A car moves with a constant acceleration 8 meters per second squared for 5 seconds. For 5 seconds. If the final velocity is 40 meters per second, comma, find the initial velocity. Find the initial velocity. 3 marks. A car moves with a constant acceleration of 8 meters per second squared for 5 seconds. If the final velocity is 40 meters per second, find the initial velocity. So this is very easy because we already have everything we need. Check out. We already have the acceleration, which is a, and it has been given as 8 meters per second squared. Then we have the final velocity. Final velocity, which we represent by v, is equal to 40 meters per second. Then we have the time taken is 5 seconds. Time is 5 seconds. Whatever we are lacking is only the initial velocity, well represented by u. Ndio hatuna. That is what we are supposed to do. Same formula we are using. Acceleration equals to final velocity minus initial velocity over time taken. Final velocity minus initial velocity over time taken. So for us to get acceleration, we already have acceleration at tuitafuti. It is 8. So 8 is equals to, our final velocity is 40. Our initial velocity we don't have, don't tunatafuta, tutaita u, over our time taken is 5. Our time taken is 5. So for us to solve that, we will cross multiply. 8 times 5 is 40. 40 is equals to, this one will be 1 times 40 minus u. So it will be 40 minus u. 40 minus u. So when we bring this to the other side, itakuwa 40 minus 40 is equals to negative u. So 40 minus 40 is 0. So 0 is equals to negative u. Even if we divide both sides with negative 1, our initial velocity will remain to be 0 meters per second. So just check this one out. 0 is negative u. If we divide by negative 1 by negative 1, it will still remain u to be 0 meters per second. 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 So by having done those questions, there is something very, very important I want to mention. So some of these concepts that I want to mention is that negative acceleration is equal to deceleration. Negative acceleration is equal to deceleration stroke retardation. When you get your acceleration as negative, it means that body decelerated. By saying deceleration, we mean brakes were applied and the body stopped. So when the body was in motion, brakes were applied, and when brakes were applied, the object came to rest or the speed went down. Sawa sawa? Yes. So it means that negative acceleration is equal to deceleration, or retardation. So it is possible to also have a negative acceleration. It's possible for us to have a negative acceleration. It's possible for us to have a negative acceleration. So we have a question here. Let's do the last example. Then tuende kwa velocity time graphs ili niwaelezee velocity time graphs. So swali ya kwanza hapa lingine tutafanya ni the velocity of a particle increases uniformly. So this is another question. Fanyeni hii hata nimewafunza sana. Fanyeni hii. The velocity of a particle increases uniformly. It increases uniformly from 27 meters per second to 57 meters per second for in 1 minute. In 1 minute. In 1 minute. Find the acceleration. Find the acceleration. Find the acceleration to max. Do that one. Fanyeni hiyo na muweke majibu kwa comment section. Na kama uko hapa na huja subscribe in Top Grade Academy, ensure you subscribe, turn on the notification bell, and everything will work out well. Immediately after this session, I'm going to have another broadcasting. It won't be live, but I'm going to upload that video today. I'll be teaching chemistry, and to be specific, I'll be teaching Form 2 work, that is structure of an atom and the periodic table. That is the topic I'll be teaching. I'm going to broadcast that, and I'm going to upload that video. It will be premiering in YouTube close to around 10:30, just around 10:30. I'll be premiering that video. So stay tuned and subscribe this, turn on the notification bell so that we will keep on learning and learning. Fanya hilo swali. Fanya hiyo. Do that question. Send the answer in the comment section. Keep sending your response. One person ametuma. And like this live, like the session, like the live, like it. You all correct? You all correct? You all correct? You are all correct? Yes, you are all correct. So initial velocity was 27 meters per second. Final velocity was 57 meters per second. And time taken was 1 minute. 1 minute is the same as 60 seconds. Remember we said time should be taken in seconds. So acceleration is v minus u over t. So your acceleration was 57 minus 27 over 60. This resonates to 30 over 60, which is 0.5 meters per second square. 0.5 meters per second square. That is correct. That is correct. So there's an examinable question I want us to do on velocity time graphs. There is a very examinable area that I want us to handle in this particular juncture. The question reads, the figure below represents a speed time graph for a cheetah. If you have Kcse made familiar, that is question in the year 2014. The figure below represents the question. The figure below represents a speed time graph for a cheetah which covered 825 meters in 40 seconds. So nitaichora so ilianza at 15. This one is speed in meter per second. Hayo ingine ni time in seconds. We have 5, 10 mpaka 30. 5, 10, 15, 20, 25, 30. Kwa imeanza hapo, around hapo. Yes. Yes. Hey. 20. 20. Nafanya hivyo ili tujue inaenda mpaka wapi. Then no. Imefika 40. Imefika 40. This is time in seconds and this is speed in meters per second. Imeanza 15. So hapa tuko na 5, 10, 15, 20, 25, 30, 35, 40. So inaenda mpaka hapo. Inaenda mpaka kwa 20. Hii nayo yote inaenda mpaka kwa 40. So iko hivyo. The reason I'm breaking is so that we can know where the peaks are. The peaks are. So I want us to do that question. The first question inasema state the speed of the cheetah. State the speed of the cheetah. State the speed of the cheetah when recording of its motion started. When recording of its motion started. When recording of its motion started. Of its motion started. Simnipe hilo jibu. Teke. Nipeni hiyo jibu. Haya. What was the speed? 15, correct? 15. Tuendelee. 15, correct. It was 15 meters per second. It was 15 meters per second. The second question, calculate the maximum speed. Calculate the maximum speed. Sasa hii itabidi tufute tu hapa. Calculate the maximum speed attained by the cheetah. Calculate the maximum speed attained by the cheetah. So, that question is 3 marks. So, for us to determine the maximum speed attained by the cheetah, for us to attain the maximum speed attained by the cheetah, what we are going to do is in this case, I want to use a different pen, a pen with a different color, so that we can be able to distinguish between these two. You remember that the board ni kidogo. If we were using Zoom, at least it has a large whiteboard compared to this board. Lakini the best with this is that there is that physical interaction with between the teacher and the students. So what we are going to do is that acha niweke ink ya blue so that we can work with a blue pen. So what we are going to do in this case, I want you to note that the maximum speed is here. This is the maximum speed. So we don't have it. It is h. We can call it h. That is the maximum speed. But we have been told that the graph, the figure below, represents a speed time graph for a cheetah which covered 825 meters. We already have the distance covered during the entire distance, during the entire journey. So what happens is that for us to determine this, we need to know how do we find the distance using a velocity time graph. So using a velocity time graph, remember, velocity or speed times time is what gives us distance. So for us to get this 825 meters, it is the area bounded under the graph. So the distance is equal to the area bounded under the graph. So when we talk of the area bounded under the graph, what do we mean? For you to find the distance on a velocity time graph, what you do is that you come here. We can take this first part alone. This is a trapezium. You can see this very well. This is a trapezium. So these are the two parallel sides, and in our two parallel sides, this one is 15, this one is h, and we have the height. With this one will now be our height, which is 10. So how do we find the area of a trapezium? We can divide this area under this graph into two. We have the first trapezium, we find its area, then we find the area of the second trapezium. And once we find the two areas, we can now add them up together to find 825. So, because of the state of our space, allow me to rub this area here so that we can do that work here. So what we are going to do in this case, how do we find the area of a trapezium? It is a half into bracket a plus b multiplied by h. A plus b is the sum of the two parallel sides. That is how we find. So it is going to be a half into bracket. What is our a? Our a is our first parallel side, which is 15, plus our b is our h, multiplied by our height. Our height is 10. From here to here is 10. We are done with the first trapezium, plus the second trapezium. These are the parallel sides. So from 10 to 20, that means this is 10. That's why nilikuwa nimeigawanya hivyo. That is 10. Then from 10 to 40, hii yote ni 30. That will be 30. What about our height? We don't have is the height. So itakuwa plus a half into bracket. A plus b is 30 plus 10. Multiplied by h is equals to 825. Don't forget h is the speed the cheetah attains. So we are supposed to determine h. So how do we go about now determining h? So we will now work it out. So this will be, we can start from any side. We can start from this side, then we open with a half. So our space ni kidogo, tufanyie hapa. So what we are going to do is, we can multiply 10 times 15, it will be 150, plus 10h, so it can be a half into brackets 150, 10 times 15, plus 10h, plus this one will be 40, 30 plus 10 is 40, a half of 40, h is equal to 825, is equal to 825. So what is a half of 150? A half of 150 is equal to 75, plus a half of 10h is equal to 5, plus a half of 40h is equal to 20h is equal to 825. We can now put our like terms together. 5h plus 20h is equivalent to 25h is equals to, we take this to the other side, we will have 825 minus 75. 825 minus 75. And once we subtract, we are going to have 25h is equivalent to 825 minus 75. 825 minus 75 is going to be equivalent to 750. It will be equivalent to 750. Then we divide both sides by 25 by 25, and that will go with that one, and we will have our height as 750 divided by 25 is equivalent to 30 meters per second. So the maximum height or the maximum speed attained by the cheetah is 30 meters per second. The maximum speed attained by the cheetah is 30 meters per second. So hapa ni 30. And we are done with that part. That is equal to 30. Tume understand? Have we understood? Kama tumeelewa semeni yes. If there is anywhere you have not understood, kindly ensure you post it down on the comment section so that I can elaborate further. So have you understood? Kindly just inform me whether you've understood. Repeat it again. Let me repeat that concept again. So where should I from here? So when we were working on velocity and acceleration questions, we didn't come across such, but we said that we are going to do most examinable areas, and I have told you that this distance, the whole distance here is 825 meters. That is the distance that the cheetah covered, and we said the distance is the area bounded under the graph. Everything you see under this graph, everything you see under this graph is the distance. So when you find the area bounded under this graph, you will finally determine the distance, which is 825. Tukakuja tukasema you can split it into two trapezium. There are different alternatives. You can have this as a trapezium on its own. You can take this as a rectangle on its own. And you can take this as a triangle on its own. There is no harm in that. So if we decide to take that, we will have three figures. Tutakuwa na ya kwanza, a half a into bracket a plus bh plus the area of the rectangle, length times width, plus the area of a triangle, a half base times height, will be equal to 825. It will be equal to 825 meters. There is no harm, even in splitting. You can see this one is also a rectangle. So why do we say that? Because if you find the area bounded under this velocity time graph, you will be able to realize it is equal to the distance. Na ni kwa nini? Because this one is velocity and this one is time in seconds. So we said that, how do we find the displacement or the distance? It is velocity multiplied by time. And the only way we can multiply the vertical axis with the horizontal axis is by determining the area bounded under the graph. I hope you have understood. So a half AB H, it will be, the AB we said is the length of the parallel sides, and the first one is 15, the second one is 30. See this one is 30 meters. So it will be a half into brackets 30 plus 15. What is our H? Sorry, just there's something I've left. We don't have our h. Hapa saa hii sasa tunaanza hatuna h. Hapa hatuna h. We don't have the h. We don't have the h. So hii h ndio tunatafuta. So tukasema itakuwa a half into bracket a plus b itakuwa 15 plus h into bracket b is our h. So usiconfuse. Hii h ingine ni 10. 10 plus length times width. Our length hatuna ni h times width ni 10. So itakuwa h times 10 plus our triangle a half times base. Base is from 20 to 40. So you unaona hii imeishia hapo. So from 20 to 40 ni 20 times h. Our height is h is equal to 825. Hata hiyo pia itatupatia. So when we do that, we are going to have a half. So 10 times 150, 10 times 15 is 150. So it is going to be a half multiplied by 150 plus 10h plus h times 10 is 10h plus 2 times a half times 20 is 10 plus another 10h is equal to 825. 825. So a half times 150 is 75 plus a half times 10h is 5h plus 10h plus 10h, that will be equal to 20h is equal to 825. Then we will take 5h plus 20h is 25h is equal to 825. We take this to the other side, itakuwa minus 75. And once we do that, we are going to get 25h is equal to 825 minus 75 is 750. And then when we divide both sides by 25 by 25, we are going to get our h as 30 meters per second. So tukakuja tukasema hiyo itakuwa nini? 30 meters per second. Tumeelewa sasa? Have we understood? Have we understood? Yeah. So let's do the second part of the question. The second part of the question is the second part of the question is asking, part C, calculate the acceleration of the cheetah in the first 20 seconds, in the first 10 seconds, part C, calculate the acceleration of the cheetah in Roman 1 in the first 10 seconds. The first 10 seconds. Hilo swali ni 2 marks. So utakuja first 10 seconds. First 10 seconds ni kutoka hapa mpaka hapa. So utakuja from 0 second when time is 0. Initial ni nini? Initial velocity. Tumia blue. Initial velocity itakuwa nini? Ama u ni 15 meters per second. Final velocity ama v itakuwa nini? Kwa 10. Juu tumambua for the first 10 seconds. Kwa 10 itakuwa final ni nini? 30 meters per second. What about our time taken? Our time taken ni from 0 to 10, it is 10 seconds. So how do we find acceleration? It is v minus u over t. Final velocity minus initial velocity. Final velocity minus initial velocity over time taken. So our acceleration will be equivalent to, our final velocity is 30, our initial velocity is 15, then we divide by time taken, which is 10. So our acceleration will be 30 minus 15 is 15. 15 divided by 10 will be equivalent to 1.5 meters per second squared. 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 Then Roman 2, Roman 2 tunaambiwa the last 20 seconds. The last 20 seconds. So utakuja mahali the last 20 seconds ziko. 1 mark. The last 20 seconds. So the last second ni ya 40. So the last 20 ni from 20 to 40, ni kutoka hapa hivi. So tukikuja hapo tutaangalia final velocity. Final velocity kwa 40, final ni 40 kwa 40. So when time is 40 seconds ni nini? Iko 0. So itakuwa 0 meters per second. Hiyo ndio final. Initial velocity iko kwa 20. Kwa 20 ni 30 meter per second. Hii ni 30 hapa. So itakuwa 30 meters per second. Time taken itakuwa nini? From 20 to 40, it is 20 seconds. How do we find acceleration? Acceleration is change in velocity, v minus u over t. So our acceleration will be 0 minus 30 over 20. And what is 0 minus 30? It is negative 30 over 20. Negative 30 divided by 20 itakuwa nini? Our acceleration is negative 1.5 meter per second squared. It will be negative 1.5 meters per second squared. 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 Remember we said negative acceleration is the same as deceleration. So this one is meaning, you see, the speed was going down. It means that the cheetah had started applying brakes. It had started decelerating. That is why we have our acceleration as negative 1.5 meters per second squared. By having that, we can do the last part of that question. So that I'm going to give you a take-home question. And after we do that, tomorrow we are not yet done with linear motion. Tomorrow we will be learning something in linear motion called relative speed. Relative speed. Let me first do the last part. Let me guide you on how to do the last part. Then I'm going to teach you tomorrow on relative speed. And relative speed is what we are going to be learning tomorrow. This is when we talk about two bodies in motion, whether towards the same direction or from different directions. That is what we are going to be discussing. Many questions that are asked in Kcse resonate within that area on relative speed. So that is what we are going to be doing tomorrow. Because of time, I can see we are now approaching 9, but let us finish up the last bit of this question. The last question is asking, calculate the average speed. Calculate the average speed. Calculate average speed calculate the average speed. Calculate the average speed of the cheetah. Part D. Calculate the average speed of the cheetah. Calculate the average speed of the cheetah in the first 20 seconds. 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 So tunafaa tukuje tujiulize 20 seconds za kwanza ziko wapi? Ziko hapa. Hata kuna haja ya kutumia hii part ingine. Hii part ingine situifute, iishe. Tubaki na hiyo peke yake. Ndio tunahitaji. Ili tupate at least space ya kufanyia kazi. 20 in the first 20 seconds. So this is time in seconds. So hiyo ndo tumeulizwa. In the first 20 seconds. So remember, for you to find average speed or speed is equals to distance over time taken. So already tuko na time taken, tumeambiwa ni 20 seconds. Tunahitaji kwanza tutafute distance. So ni distance hatuna. And for us to find the distance, we said that for us to find the distance of an area bounded within the velocity time graph, we determine the area bounded. The distance is equivalent to the area bounded. So if you check this clearly, this one here is a trapezium. So the distance will be equivalent to the area of a trapezium plus the area of a rectangle. The area of a rectangle. Let me use paradesi. So that is what we are going to do. So for us to get the distance for the first 20 seconds, it will be distance is equals to a half into brackets. What is our A? 15. What is our B or our H here? We found it as 30. Then multiplied by H is 10 plus length times width, it is 10 times 30. 10 times 30. And by doing that, we will get our distance as 15 plus 30 is 45. 45 times 10 is 450. And a half of 450 will be equivalent to 225. A half of 450 will be 225. Plus 10 times 30 is 300. So when we add up the distance covered within the first 20 seconds, it will be 525 meters. So we already have the distance, we have the time, which is 20 seconds. I want us now to determine the speed. Speed is distance over time taken. So distance is 525, divided by time taken is 20. So when you divide 525 divided by 20, what are you going to get? What are you going to get? So 525 divided by 20, it will go 2 times because of 40. We subtract 2, we remain with 1. Then we drop 5. 20 times 6 because of 120. Then we drop 5. Then we put a decimal. We put a 0. 20 times 2 because of 40. Then we subtract, we remain with 10. Then we add a 0. 20 times 5, it will be equal to 100. We subtract, we get a 0. So our speed will be 26.25 meters per second. 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 So, do you have Kcse made familiar books? Do you have Kcse made familiar? If you have it, just write I have. Just write I have on the comment section. Write I have on the comment section. Just write I have on the comment section. Do you have Kcse made familiar books? Just say I have on the comment section. Just say I have on the comment section. Just say I have on the comment section. Because if you have it, I want you to work out on 2009 paper 1 number 22. Just do that question. It is 10 marks. Tomorrow we will be working out on relative speed. Relative speed. If you are interested in my services, my contact is +2547420900825. You can reach me out through this number or through this contact. You can reach me out through WhatsApp. You can make a call. I'm going to respond so that I can assist you in your academics. How to revise effectively, I'm going to guide you on that at just a cup of coffee price. So, for the sake of private tutorials, this is it. If you are out there and you are very, very passionate on sitting for Kcse examination 2026-2027 and you are in need of a teacher to take you through mathematics, chemistry, biology, and not just that, even other subjects, Top Grade Maths, Top Grade Academy is here for you to give you the services that you need, and I will be glad to assist you through and take you through your academic journey. This is your one and only Teacher Asaf, who turns confusion into confidence. Until we meet next time, that is tomorrow. And if you are going to get a chance to watch the video I'm about to make on structure of an atom and the periodic table, ensure you follow up for more. Have a blessed evening. Have a good evening. I've said this is the assignment 2009 paper 1 and number 22. It is exactly just a question. It's a question just like what we have just done. Take your time and do that question, and I believe everything will work out well. Do you have made familiars? Okay, yes, I have seen you have replied yes, you have the book. Ensure you do that. Have a blessed evening.